In this video, we're going to look at the last bit of notes for section 1.1. So in this section, our focus has been entirely on problem solving. We've been talking about, with problem solving, different strategies, different approaches and techniques we could use whenever we're faced with a challenging situation, a word problem, some type of mathematical scenario, different ways we can try to think about approaching that and solving that situation. So we have two strategies left in this section that we're going to look at. The first one is the order principle. Essentially what this is saying is that, as the name may imply, order is extremely important. You have to be very careful, especially when we're dealing with something and there are multiple operations that have to be performed. We need to pay careful attention to that order that the operations have to be performed in. Just like there's certain things when you're going about the day that you have to do in a particular order. Okay, very simply, getting up, getting ready to come to class or to go to work. When you're getting dressed, you got to put your socks on before you put your shoes on, right? Very simple thing, but the order is important. And sometimes we know in different areas, if we don't do something in a specific order, those results that we get may not be the desired or acceptable results. So with that also ties in with mathematics. That difference could give us an undesirable result if we don't perform things in the proper order when it comes to our order of operations. Now, something to note on that is that we're not always saying that it's always wrong to reverse the order of our mathematical operations. We are just saying if the order is reversed, that you could accidentally change the meaning of your calculations. Okay, so let's look at a couple of scenarios to kind of think about this. So we want to, in our first example 10 part A, we want to decide whether the two sequences of operations are going to give the same results. So the sequence is that we are going to square a number, then add 6 to it, and then the second sequence we have is adding 6 to a number and then squaring that sum. So our starting point here needs to be establishing a specific number. So just choosing any number that we want. So let's say the number that we choose is 2. So I'm going to use that number for both sequences to see if we get the same outcome if we change the order that we perform these operations in. So in the first sequence right here, we are squaring a number. So we're taking the number we just established 2, and we've got to square it. So it says we're going to square it first and then add 6 to it. So if we square 2, 2 times 2 is 4. And now that we have done that, we go ahead and we add 6 to it. So 4 plus 6 is going to give us 10. Okay, so that would be our outcome if we follow that sequence in that specific order. Okay. The second ordering for that sequence is if we add 6 to that number first. So we're going to take 2, we're going to add 6 to it. That would give us 8. And now that we've done that, we go ahead and we square that sum that we just got. So now we're going to do 8 squared. So 8 times 8 is 64. And so comparing those, we were trying to decide initially whether the two sequences give the same results. Well, we can see here, since one of them gave us a final value of 10 and one of them gave us a final value of 64, we would say that they will not give the same results. Let's do another example with that same strategy. All right. Adding two numbers, x and y, then dividing the result by 2. So that's one situation that we've got, or one scenario. And the other scenario would be dividing x and y by 2 and then adding the results. So first, we need to acknowledge the fact that we have two numbers we're dealing with, x and y. So we need to just assign values to both of those. Now, I am going to let both of them be even numbers because we have that component in both sequences where we are dividing by 2. So I'm just going to let x equal 6 and y equal 4. And again, I said I'm choosing even numbers because one of the steps in the sequences is to divide by 2. And so just to make that easier and to ensure that we have whole numbers, we're going to make both of our initial numbers even. So in the first sequence, it says we are going to add the two numbers first. So 6 plus 4 would give us 10. And now that we've done that, we're going to take our result, 10, and divide it by 2. Doing that gives us a final outcome of 5. The second sequence says, what if we take each number individually and divide them by 2? So if I do that, 6 divided by 2 would be 3. 4 divided by 2 would be 2. So I've divided each individual term by 2, and now I'm going to take the result and add them together. So 3 plus 2 would give 5. Okay, so now comparing those results, we do see that the sequences will in fact give the same results. So that is one of the strategies that we have in this video. The second and the last strategy in this section is called the splitting hairs principle. So when we're talking about splitting hairs, being very particular on things, being very decisive and nitpicky, when it comes to mathematical terminology, that's when you really want to split hairs. That's when you really want to be nitpicky and be very particular and very specific, because we can have two things that are similar but sound slightly different. And in that case, they do not usually mean the same thing. So we know that in English, when we're just having a conversation, we have the words equal and equivalent, and we use those interchangeably. However, in mathematics, they don't mean the same thing. Okay, this also ties over to the notation we use. Just like in English, we have specific grammar we use when we're writing essays. In mathematics, we have specific notation we use when we're working problems, we're presenting our findings and our answers. And so the notation matters just as much as the grammar matters when you're writing a history paper or an English paper. So when we encounter different looking notation or terminology, we want to make sure we get a clear idea of exactly what the difference is. And so, like we said, representing your ideas precisely is a part of good problem solving. Just like using that proper grammar and punctuation is crucial when you're writing an essay for history or English. Okay. So we have a couple of examples here where we are just very simply looking at differences in pairs of symbols. So with part A, we have 5, okay, and then we have another 5, but it's surrounded by some braces. So if we're just explaining the differences, all we're doing is stating what we are seeing. So with part A, 5 is very simply a number. And then we have that second one where we got 5, but it's got some braces around it. So there are these little curly braces, which we will talk more about that a little later in the semester. But for right now, just explaining the differences, this is very simply a number with braces around it. Part B, okay, we see there's a U. There's actually two U's. And so what's the difference between them? Well, at this point, keeping it very basic, very simple, just to get us to be attentive to the details and to the little things and differences for when we move forward, we can see that the first one is uppercase, and the second one is lowercase. So pretty straightforward, but we point out those things now so that later in the semester, when we start looking at different types of mathematical notation, we can be aware of the differences. Even though they may look similar, there are differences depending on the specific notation that's being utilized. Okay, so that is everything that we have in section 1.1, which was all about problem solving.